Okay, we're going to start a little video tutorial on exponential functions in standard form. So the standard form of an exponential function is going to have to look the same every time. So a function is going to have a function notation like this. It's going to equal some rule where that rule has an initial value, which we call the AO value. And then it's got the exponential part, which we call the b to the x. So the AO is kind of like a coefficient. Value. So it's the start value. And we will generate those. And we will also find out where they come from. This b right here is what we call the base value. And then up here is our variable. So as you can see, in standard exponential form, the AO, or the coefficient, is a number that has no exponent on it. The base is a number that's then being raised to a variable, and the variable has no other multipliers to it. It's just the x, or just the variable, all by itself. Okay, so we're going to utilize a couple rules. Those rules that we are going to utilize are the fact that if I have x to the m plus n, I can turn that into x to the m times x to the n. So another example, if I had 2 to the x plus 3, then I'm going to turn that into 2 to the x times 2 to the third. Where I'm adding, since I'm adding the exponents here, I can give each of them to the base and write it as a number to the variable and a number to the other portion, or in this case is the 3. So one last time, 3 to the x plus 4 is going to turn into 3 to the x times 3 to the fourth. Now, in these exponential problems, we're typically going to be given something that starts with like this. We're going to have to go through a process of breaking it apart so that we can eventually end with something in standard exponential form. So since 2 to the third is 8, there's no more exponent here, it's gone, that becomes my AO value. And since 2 to the x is now a base with a variable that has no other multipliers, my function in standard exponential form of 2 to the x plus 3 over here now becomes 8 times 2 to the x. Alright, we'll do the same process with the second example. We started out with 3 to the x plus 4. We moved into 3 to the x times 3 to the fourth, which then gives us 3 to the fourth times 3 to the x. 3 to the fourth is 3 times 3 times 3 times 3, which is 9 times 9. So this is 81 times 3 to the x. So there I've got 3 to the x plus 4 into standard exponential form. I've got 2 to the x plus 3 into standard exponential form. And now we're going to show you a couple other examples of these. Okay, so what if I have not a x plus something in the exponent? What if I have 2 to the 3x? What if I have a multiplication problem up there in the exponent? Well, I'm going to utilize this rule. X to the m times n is x to the m to the n. So it's a exponent problem raised to another exponent. So in this case, instead of going this direction, I'm going to go this direction. So I have my multiplication problem, and I'm going to go this way and turn this into 2 cubed to the x. So I broke up the 3 times x into the 3 down here and the x up here. Now, 2 cubed is 8. X is all by itself. And there is no AO value. It's actually 1. But when I multiply 1 times anything, I don't really need it, right? So I kind of can just take that 1 out. I don't even have to worry about it. So if there's no plus something over here, then the AO value is a 1, and I don't even have to worry about it. Okay, so 2 to the 3x is the same as 8 to the x. So that is now in standard exponential form. All right, let's try another one. 4 to the 1/2 x. Well, I'm going to break 1/2 x into 1/2 times x, which then is going to allow me to go 4 to the 1/2 to the x. Well, taking something to the 1/2 power is like taking my x, my index, and my base, or my radicand, which is now 2 to the x, right? So what started out here, I break it up, and I simplify it over here. Since there's no plus anything, the coefficient is a 1, and 4 to the 1/2 x is the same as 2 to the x. Okay, so I'm going to give one last example here, and then you'll be caught up to speed. So let's try one that has a combination. Let's say 3 to the 1/3 x plus 4. Okay, so I'm going to kind of combine the two. Well, I've got a binomial portion, right? I've got a plus sign here, which means I'm going to have to deal with that, and I'm going to have to deal with that. So let's deal with the 2 parts to start with. So I'm going to deal with the plus sign first. So I'm going to go 3 to the 1/3 x times 3 to the 4th, right? Which is taking care of the plus sign. Now, I'm obviously going to have an AO value. It's going to come out of that 3 to the 4th piece right here. That's going to be my AO value. And then, so that's going to simplify to 81, because I know that from before. And then my 3 to the 1/3 x is going to be the cube root of 3, right? Because there's my index to the x. So this piece over here becomes the cube root of 3 to the x. So 3 to the 1/3 x plus 4 becomes 3 to the 1/3 x times 3 to the 4th, which then simplifies to 81 times the cube root of 3 to the x. And you can see now I've got my AO, which is 81, my B, which is the cube root of 3, and my x, my variable, all by itself. So the task that we're going to be working on is taking things that are not in standard form and turning them into something that is in standard form. Okay, so these are just exponentials, and then later we'll deal with the graphs and calculating and all those good things. All right, so there's your tutorial on exponential functions and simplifying them. See you soon.